Hello, lovely viewers. This is your boy Palmer 12. Come on your way this day 2. We are going to continue from where we ended the other time. Now, the other time we started something about multiplication of algebraic expression. That is under the simplification of algebra. We first looked at the addition and subtraction of algebraic expression. We solved some examples, and then we also came to the multiplication. We introduced the multiplication of algebraic expressions. We also looked at some ways which an algebraic expression will be given to multiply. And today we are going to still look at simplification of algebraic expression by multiplying them. So today's lesson we are going to look at algebraic simplification as we done earlier. Now specifically we are going to look at multiplication of algebra. Now under the multiplication of algebra, now we've learned something about it already, but let us look at the rules that governs the multiplication of algebraic expression. Now the rules that govern this is, the first rule is multiply the coefficients of each variable. So no matter the amount of variables found in a particular expression, you multiply each coefficient, then after that you multiply the variables. So you multiply the coefficient of the variable, then you multiply the variable itself. Now let us go to our writing board and then show some illustration or some examples of what we are talking about. So we are starting from the basics and then we will move on. It's not that advanced, but we will move on. Alright, so the basics, let us take an example of, say, have 2x multiplying 5y. 2x multiplying 5y. Now if I am asked to simplify this particular expression, then I have to seek to read that the coefficient of x here is 2, the coefficient of y is 5. Now the rule is saying that multiply the coefficients of the variable and then multiply the variable. Alright, because the coefficient of the variables are numbers, when I multiply them I will surely get an answer which is also a number. So in short, if I multiply 2 and 5, my result is going to be 10. Then when I multiply x and then y, my result is going to be xy. Alright, so that is the simple simplification of this particular variables or these particular terms. Let us take another example too and see how to solve it. Now if I have 6m multiplying, say, n, 6m multiplying n. Now the rule still holds. Now we all know that anytime there is a letter or a variable without a number, we say it has a number of 1, that is a coefficient, but we do not write it. So in actual sense, 6m multiplying 1n. So we multiply the coefficient of m and n. So 6 times 1 is going to give us 6. And then m times n is going to give me mn. So my answer for this particular expression is going to be 6mn. Okay, so let us take another example where we will have variables that are alike, as we discussed in our previous video. So for example, if I have, say, 3t times 5t to the power 3, say 5t cube, right? So power 3 is known as cube and power 2 is known as square. Alright, so the rule still holds. Now the only difference between this and what we've solved previous or earlier is that here the variables were not the same. They were different variables. X and y are not the same. Though these variables, if we are to talk of like terms, they are not like terms, but they are of the same variable. So we can say t is here, and then we also have t here. I have t here and I have t here. So though they are not like terms, but they are the same variables, right? So the difference between this example and these examples are or is these have the same variables, but these have different variables. And how do we solve question like this? Now when it is given to you, it is just like we did over there. We multiply the coefficient. So we multiply the coefficient over here, which is 5 and then 3. So I'm going to have 15. Now the t over here, instead of me to write t times t to the power 3, we apply some rule of indices, and it says that anytime variables are the same and they are multiplying, you write it as a single variable and then add their exponent. So to me, the exponent of t for the coefficient 3 or the number 3 has or is 1, and that of 5 has 3 as an exponent. So in actual sense, I can write this as t exponent 1 plus 3. So this is going to give me 15 exponent 15t exponent 4. Okay, so that is the simplification of this particular expression. Okay, let us still solve some questions which are very simple. We are not going to questions which are very difficult. We are looking at the simplest ones. So now let us look at when I have 3 variables multiplying each other. For example, if I have 2s times 3ab times xy. Okay, so we have these and we are asked to multiply them. The rule still holds. We've not changed any rule here. The rule is saying that we add we multiply the coefficient of the variables, and as we all know, the coefficient of this variable here is 1. So if it is not written, that is what you should see. So there is a coefficient of 1 here. So we multiply the coefficients that we have over here. There is a coefficient of 2 to the variable s. There is a coefficient of 3 to the variable ab. There is a coefficient of 1 to the variable xy. So if for me to multiply these variables, I have 2 multiplying 3 multiplying 1, which is 2 times 3, 6, and then 6 times 1, which is going to give me the same 6. So in short, when I multiply the variable, I'm going to get 6. Now the coefficient, did I say variable? When I multiply the coefficient, I'm going to get 6. And the variables over here, because there is no like variable, you multiply every variable, and take note, you can arrange it in alphabetical order. So we are going to have 6 A B S X Y. Alright, so that is the simplification to this particular algebra. I hope these are very simple.